Okay, so when I made that slide, I kind of intended that to be a rhetorical question, but I kind of have to acknowledge that A, I have a massive cold, B, that spending 12 hours in an airplane didn't help that, and C, I'm not entirely sure whether buying and eating all of the cold medicine available at the airport was ultimately a good idea or not. So if at any point during this talk I actually seem like I don't know where I am, please have some patience with me. Thank you. So, excuses out of the way, question, where am I? So a fairly profound but also profoundly unhelpful way to answer that question is to say, you're here, right? This is a picture taken by the Cassini space probe 900 million miles away from Earth, and that little dot down there is actually Earth, and you are there. That is fundamentally true for every human being in the world, and also for every human being who has ever lived, really. Every human being who's ever been or will ever, well, hopefully not will ever be, but for the time being has been on or at least very, very near to that dot. I want to look at another kind of dot, a more helpful kind of dot that we kind of use in our everyday life to answer that question, where am I? And I'm talking about that little dot that shows up on your map application, right? Whenever you're asking yourself the question, where am I, you tend to pull out your phone and you start your Maps app and you get that little dot that shows you exactly where you are. And that's actually an amazing technological achievement if you think about that, right? Because we're never really lost anymore, right? In fact, you could almost argue there's an entire generation that's now grown up that doesn't really know the feeling of being lost anymore. Because all they need to do is go reach into their pocket, pull out a phone, and they can figure out where they are. They can also figure out where they want to go, and they can also figure out how they want to get there. And if you forget that you're doing, for a second, that you're doing this every day and it's completely natural to you, it's really quite amazing that we can do this. And in many ways, location technology has become an integral part of our daily lives to the point that we don't necessarily even realize it anymore, right? Sort of the most profound technologies that exist sort of tend to weave themselves into our lives to the extent that we almost start to forget that they exist and how amazing they are. You think about something like writing, right? Or printing. Those were amazing technological achievements at their time. We just take them completely for granted. We don't really perceive them as technology anymore. And location technology is almost sort of getting to that point where we sort of take a lot of it for granted, right? We tap on some things in the internet and hot food arrives at our door while we play with our drone in the garden. We can't even imagine driving a car anymore without having a navigation system to rely on. I struggle to imagine how people ever got anywhere. Honestly, just a few years ago, like when my dad drove us on holiday with the car to Italy, it still blows my mind we actually got there. I couldn't do that. Or, packages arrive at our door every day. And all of these things involve, at some point, location technology. And we almost don't even notice that anymore. I don't want to spend too much time trying to convince you that location technology is totally awesome, because presumably you're sitting in this room and not in any of the other rooms because you have some sort of interest in this. I do want to tell you one little anecdote which I kind of love, which is a story about Jon Snow. Not that Jon Snow, actually. That Jon Snow knows nothing. I'm talking about that Jon Snow. That Jon Snow is often considered the father of modern epidemiology. He was a doctor in 19th century London, and there was a large cholera outbreak. And what he did is he said, I want to figure out where this actually comes from, because back then people didn't know. Right? They didn't really understand microorganisms and disease transmission, and they thought cholera came from something they called miasma, sort of weird poisonous vapors that were going through the city. And they had no idea that pooping in the water is actually maybe not that great an idea. And so what he did is he got a map, and he started to mark down where cholera cases were happening. And you can see these little boxes, these little black boxes here. And wherever a lot of little black boxes are stacked, is where a particularly large amount of cholera cases was. And he was ultimately able to trace this down to a single water pump on a street corner. And even at the time, a lot of his genius in that way wasn't necessarily immediately recognized, but ultimately this led to things like development of the modern sewer system and us stopping to poop in our water, which is fantastic. So,
the pump handle and the epidemic stuff.
Exactly. And so in that way he became, and that's kind of how we proved that it was actually connected to that. It wasn't just an idea, it was actually real. Despite this, it wasn't immediately recognized, but ultimately he became known as the father of the modern epidemiology. And in many ways, he's also kind of the father of what we would now call location intelligence, which is to say, gaining insights from location data. So I also know nothing, particularly in my current state. My name is not John, my name is Richard. I'm a developer evangelist for Here Technologies. I'm always a little curious. Can I get a show of hands how many people have actually heard of Here Technologies? No, it's not too bad. We're sort of a bit of a hidden champion. We're the world's leading location data company, but because we work with a lot of businesses behind the scenes, a lot of people haven't necessarily heard of us. All of the things I was talking about earlier, from the navigation system in your car to packages arriving at your door, more likely than not, when you're doing these things or flying your drone or whatever, in some way we're involved in that, but you don't necessarily know. I'm also on Twitter. I'm really bad at Twitter, so if you enjoy crushing disappointments, this is where you want to go. I will make the slides available there, though, so if somebody asks you why the hell you're following this weird guy, you can just say, I was young and needed the slides. Quick sort of setting of expectations, because there was some weird communication going out. I think at some point I got out of a plane and there was an email and says, Richard's going to talk about triple reverse time travel bypass surgery or something, and it was really confusing. So this is a beginner talk about map and location APIs. I'm just going to talk sort of about, the general concepts, and we'll also look at some APIs in action. It's mostly going to be REST APIs, JavaScript. I might throw a little Android in there. All of the stuff I'm talking about, or most of the stuff I'm talking about, you can get on our developer portal, developer.here.com. We have REST APIs, JavaScript APIs, we have Android and iOS SDKs as well. There's free trials and everything, and you can sign up there, and everything we're going to talk about here today, you can try yourself. Okay, so back to the question of where am I? Maybe we can just try to answer that question with a little bit of code. So this is not one of our APIs. This is the this is the cold working 3C standard for browsers, and each browser manufacturer sort of implements that in their own way. But in the browser, you can get a geolocation object, and you can ask it for its current position with get current position, and then it'll return you a latitude and a longitude. And we'll talk about what that exactly is in a minute, but we can actually just very briefly have a look at that code. Where is my interesting? There you go. And as you can see, this is literally just those 3 lines of code thrown in a script tag on an empty web page. And if I open this up, the browser will ask permission, allow location access, and then a second or 2 later, we should see 2 numbers appear. I don't have internet, and of course that doesn't work, and I should probably activate internet, because otherwise this is going to be, what is it? We are hiring? Hiring now. Okay. Hiring now, all capital. Let's see if this works. Connecting. Nope, I can't type apparently. Let's try this again. So what'll show up here, hopefully in a second or 2, is basically just 2 really weird numbers. And those will be a latitude and a longitude. I am connected. Let's do this. Allow location access. And there we go. So there's 2 numbers. It's 37.3 something something and minus 121.9 something something something. So that is our location, even though that's not necessarily a particularly helpful answer, and also it's not quite our location. We'll talk about that a little bit later, maybe. Here's another example. If you're using our here Android SDK, there's something called Positioning Manager, and you can tell it to start, and then get position will give you a geoposition object, which also has a latitude and a longitude in it. So you can get this with very little code, but what the hell does it actually mean that we are at 37.3 minus 121.9? Well, those are latitudes and longitudes. And basically, people thought, well, if we want to locate things, why don't we just draw a grid? And then with 2 coordinates, we can find ourselves on that grid. The wrinkle with that, of course, is that the Earth isn't flat, so drawing a grid on is a little bit tricky. And they did it by drawing 2 main lines across the world. One is the equator, which sort of goes around the middle of the world. And the other is the prime meridian, and that starts at the North Pole, goes to the North Pole, and goes through the Royal Observatory in Greenwich, London, because people who worked there wanted to feel important. And with the equator, then we start drawing these parallel lines going around the globe, and you may have heard the term parallels. That's where that comes from, because you're drawing these little parallel lines, lines parallel to the equator around the world. And as you're going up north, you're starting to go upwards towards 90, and when you're at 90, you're at the North Pole, and going south, you're starting to count down until you're at minus 90, which is the South Pole. With the meridians, it works slightly differently. They're not actually parallel to the prime meridian, but they all start in the North and the South Pole, and you start sort of counting around the planet. If you're heading east, you're starting to count plus until you're at 180, and as you're going west, you're starting to count minus until you're at 100, minus 180. And that's a very short overview of a somewhat complex subject. But if you know this, you sort of have an idea of where that latitude and longitude might be on the planet, right? So if our latitude is 37-something, we're in the northern hemisphere, clearly, because it's a positive number, and we're sort of not entirely halfway up the way to the North Pole. And at minus 121, that means we're very, very far west of London, not quite at the other side of the world, quite a bit. And if you think about it, that sort of matches up with where we are in San Jose, right? So now we have a latitude and longitude, and we sort of have if we look at a latitude and longitude, we can sort of roughly point towards on the globe where we are. But sort of the question now comes, where, if we use these APIs, does that number actually come from, right? And if we use the Android SDK, the answer is probably, and in fact there's a little spoiler in there that you can see here, where it says GPS network. It's probably from GPS, right? Satellite navigation. In fact, that's what most of us probably think of when we think about getting our location. And this is true, but it's also not completely true, because there is more than just GPS. We might have also gotten that location from Galileo, or from GLONASS, or from Beidou, maybe even from Navic or QZSS. Basically, there's more than one satellite navigation system in the world, which is why we use that overall term GNSS, Global Navigation Satellite System. Galileo is the European version, GLONASS is the Russian version, Beidou the Chinese version. The other two are Indian and Japanese, and they're actually not global systems, they're regional systems, or in the case of the Japanese system, it's 3 satellites they're putting up to actually augment GPS over Japan. And in fact, modern phones, yes? Yes, these are all satellite networks. So the US has shot up a lot of satellites, and that's the GPS signal. Europe is in the process of shooting up a lot of satellites, which is the Galileo system. They're all separate satellite systems, separate systems. And in fact, your hardware needs to support this, right? Most standard hardware, most phones just support GPS, but there are phones now which support Galileo, GLONASS, etc. So for example, I know some people at Galileo, and when Apple recently announced that they would add Galileo support to the iPhone, they were quite happy in that office, I can tell you. Yeah, so location technology has, the question was, why are there so many, okay? Because location has always been of incredible military importance. In fact, for a long time, it's really, really difficult to find out what your longitude is. And there were governments were handing out large prizes for someone who would be able to tell this on a ship. And of course, that was about military application. And yes, GPS is ultimately controlled by the US government, and everyone who thinks of themselves as a world power or aspiring world power is putting up their own thing. In fact, Galileo, the European system, is the only system, I believe, that is in actually a private or a government, not a military system, right? I'm not actually sure about the Japanese system entirely. So that's not the only way to get location. For example, this laptop doesn't have a GPS chip, right? So, and we still got a location. How did we get this? Well, there's multiple ways to do it. And for time reasons, I'm not going to talk about the one the browser probably did it, which is getting the address via IP, which is a bit weird if you think about it, because IP addresses don't really have a location associated with them, at least in theory. In practice, the way they're used and distributed actually means there often is, and there are companies out there that sort of build these databases. And that's very often how a browser will get it. That's very, very imprecise, though. I tried this in the hotel yesterday, and it thought I was like about 50 kilometers to the west. A more interesting way is to use radio signals. Right? We're surrounded by a crazy amount of radio signals. We have cell towers, we have Wi-Fi access points, we have Bluetooth beacons, et cetera, et cetera. And if you have a database of where these cell towers and Wi-Fi access points are, and you yourself can sort of tell which ones you can see and possibly know the signal strength of them, you can actually figure out where you are. And this is what a lot of positioning APIs do when they don't use a satellite navigation system, right? So this is our positioning API, and you can see there's an endpoint and only two parameters, which are the credentials. You can get those on the developer portal, and I'll leave them out in further examples because that would just be superfluous, but you need this for everything. Get them for free on our developer portal. And then you do a post request, and you take a JSON formatted list of all the wireless access points around you that you can see. And what you do is you send the BSSID, which is the unique identifier that they send, and that's usually the MAC address of the device, which is why you see a list of MAC addresses. Yes?
So you're saying on the non-satellite location databases, you pre-compute all of that, and your browser just queries that database?
Yes, exactly.
It's not going to be the
No, I mean, there's sort of a database on our side, and we know where the cell towers are, and we have a database of all the Wi-Fi access points, and I basically just say to the API, these are the wireless access points I can see, or you can also do this. This is the example for Wi-Fi, but you can also do this with cell towers, GSM to LTE, and so on. And then on our side, we calculate based on that where you should be. And I can show you this in action. Let's fire up Postman and have a quick look at this example. If we send this up, so you can see here we have the body with the MAC addresses, and it's a list of access points I know I can see in our office in Berlin. And then if you go down here, you'll get a nice little JSON response, and it tells us a latitude, a longitude, and an accuracy. And the accuracy basically means that the positioning API thinks that you are within 166 meters of that latitude and longitude. And if you look at this, latitude 52 means you're, again, northern hemisphere, slightly further up north than we are here, and a little bit east of London, which is where Berlin is, right? It's just slightly north of London and a little bit east. So that kind of makes sense. That's sort of the result we would expect there. Yeah?
So to improve the accuracy, can you give the signal strength?
I'm not sure. I'd have to actually check if you can do this for the Wi-Fi. I think you can do this for the cell tower stuff, but I can look this up for you afterwards.
Because ultimately, the accuracy for the Wi-Fi without signal strength depends on how many access points are around.
Yeah, signal strength certainly helps, though of course with Wi-Fi, like that law of inverse square doesn't perfectly apply because there's walls in there. It works a little bit better with cell towers, I suspect.
But essentially, if you're in a rural area and you see a single access point,
Yes, that is true.
your accuracy is
Yes, but again, it's in that case, if you have no access points, it doesn't work. It doesn't work at all, right? The more access points you have, the better it is. So this is something that actually works better in an urban area than in a rural area, which is funnily different from GPS, because GPS has trouble if you're around lots of buildings, because the signal gets blocked, or it might even get reflected, and then you might get a slightly false reading. So ideally, you can also combine this. And in fact, with the here positioning API that on Android that I showed you earlier, you can actually put in as a source, use GPS and use Wi-Fi. And so you can sort of fuse these various things together and get a better response. So to answer the question, where am I? To figure that out, you can use a positioning API. Just make sure you understand the technology that the location comes from, understand that we've just talked about this in different application scenarios. One thing might work better than the other, and make sure you choose the right API for the task, and also the device that you have, right? GPS is great, but if your device doesn't have any GPS, you just can't use it. Okay, now we have a latitude and a longitude, and we have a rough idea of what the latitude and the longitude is. But by itself alone, that's not necessarily super helpful. Sort of, we've been able to roughly pinpoint where we are on the globe, but in many ways, the power of a latitude and a longitude is that it can place us on a map, right? And that's really what we think of in many cases with location data and location technology. We kind of think of maps. Now, it turns out making maps is hard. This is a map from the late 16th century, a Dutch map of what is supposed to be New Guinea. I've tried to match this up with modern maps. Those islands in the middle are supposed to be the Solomon Islands. I've not been able to make any sense of it, and the cartographer probably didn't either, because if you look at the lower half, at some point he just went, there be dragons, right? So making maps is hard, and even to this day, there's actually very few entities who make their own maps, their own map data. We're one of the few companies that does this. And not all maps are the same, right? So it's worth looking at quality and coverage when you are picking whose map you are going to use. There was an interesting story recently that I read where someone had started building a really expensive building and didn't have all of the funding for it and was missing like $7 million, but was going to be okay because there was some government funding that would cover the rest. Except they hadn't looked at the right high-quality map, and when they had a half-finished building and applied for the final funding, the government said, this is really nice, but you're not actually in the area and the region where the funding applies to. You are 50 meters further to the left. Sorry. So sometimes map data can be really mission-critical. So it's worth considering things like quality and coverage for your specific application before you choose a map provider. There's other ways, too, though, how maps can be different, even if they're from the same company. And in this case, this map is from us. Can you see the difference? It's slightly hidden. I've highlighted it here. So one of the maps is, so this is the southern tip of South America, like the Tierra del Fuego down there, and the sort of the southern end of Patagonia. You have Chile and Argentina that you see there. And both of those countries have a slightly different perspective of what the border looks like in one of those areas. This is not one of the most explosive border disputes in the world. Another example would be that probably a map of the Ukraine and Crimea would look very different right now if you looked at it from a Ukrainian perspective versus from a Russian perspective. And that also means that maps can have political and legal implications when you display them. So that's always something to keep in mind. Anyway, let's get some maps into our applications. How do we do this? Well, there's basically two ways you can do this. One, which we call the map image API, is basically an API that gives you static map images, literally JPEGs or PNGs of a map that you can use. And the other is what you're probably used to when you are interacting with maps and applications, which is a nice map that you can move around and zoom around and click on a button, and then the satellite imagery appears and so on. Now, if you can have that really fancy interactive map on the right, why would you even want a simple thing like just a map image? But there's actually many kind of cool and useful applications for this. Think of chatbots that want to send you some location information. They can just send you an image. Think of an Alexa skill that kind of displays your morning traffic in one of those skill cards in the Alexa app, or those new devices, they now have screens, so you can do that there as well. So there, and of course, if you're kind of memory or resource constrained on the device that you're on, that can also be very useful. So let's have a quick look at that. Again, here's a simple example. There's an API endpoint and a couple of parameters. And the first parameter basically is a latitude and a longitude. So there's something very similar to what we just discovered. And that basically just says this is what the map is centered on. Then there's a zoom level. And this basically just says how close or how far are we to the map. If we set the zoom level very, very high, you basically have a map of the entire world centered on San Jose. If you zoom in really closely, you'll basically see a few houses on a street in San Jose. And you can also say, I want the image that it returns to me to be of that size. And we can have a quick look at that in action as well. Clicking on Postman, looking at the map image API. So we can see we've got these parameters in here, and we can say send, and what we'll get is an image of a map, which is really nice. We can also play with some other parameters here. We can, for example, set the T parameter and set that to 1, and we'll send that off, and we'll see that actually changes the type of map that we get. So right now, that's just a satellite image. Or we can say 3, and it'll give us a combination of satellite image and the street information that we've just seen. This is actually a fairly powerful API with lots of features that's worth exploring. Here's another example. If you change the endpoint slightly up there from map view to route, and then feed it as a parameter a number of waypoints and a line color, you can actually draw a route on that image. And again, we can have a quick look at that in action. If we send this off, we see that we have an image of a map here, and a street on it is basically highlighted. And you can put markers on this and a lot of other things. It's actually a fairly powerful API, given the fact that the return is the return value is a simple image. Now, let's look at interactive maps, right? And we're going to look at our JavaScript API to put maps into web pages, kind of the way you're probably used to it and interacting with it most of the time. So for that, that's also just a few lines of code. First, you have to set up a platform object. Again, you need an app ID and an app code. Then you create a layers object. In this case, we create a default layers object. And layers is what we've just seen. Sort of maps consist of layers. There's like a terrain information and road information and maybe a satellite imagery information, or maybe a layer that has traffic information where the roads are red if traffic is slow. And then we create a map object. We just tell that map object which element in the web page it lives in, tell it what kind of the default layers we want it to see, and then we create a behavior and a UI object. And again, we create defaults here, and the behavior basically tells you how the map behaves if you interact with it, and the UI basically gives you some nice buttons for zooming and changing to satellite view and that sort of thing. If we look at this again in code, then we can look at this, and again, I've just thrown this into a simple web page, and this is the boilerplate stuff we've just seen, and then I can do simple things like say map set sender and map set zoom to get it to a specific location. And if we end up opening this, we'll see that we have, if the internet works, it does, a little bit slow, a very wide, because I didn't set the size correctly, very wide map, and you can see I can just move this around, and I can zoom in and out, and I can switch to satellite, and you see these UI images and all that behavior. You can just modify that to your heart's content. Because the internet is slow, you can actually just see those map tiles, those little squares sort of loading in. And in fact, this API is built with an API called the map tile API underneath. And you can just basically, if you want to, you can use that map tile API to roll your own interactive maps API, or you can plug those map tiles into another system that maybe has all these things done and just switch out sort of the map provider underneath it. Okay. So coming back to the question, where am I? One possible answer is actually I'm at 2161. I'm German, so my guess is the N stands for north, but I'm not. Okay, people are nodding, that's good. North 1st Street, San Jose, California, 95131. Now that's how probably most of you found your way here, because that's actually the address that's on the web page of Silicon Valley Code Camp, right? But a computer doesn't really understand that, right? A computer wants latitudes and longitudes. We've plugged that into the APIs. Whereas this is my office address in Berlin, and as you can see, we do things completely differently, right? We put the house number after the street. We don't put the state in the address. We have states, but we don't put them in the address, and the zip code actually goes in front of the city, and we don't even want to start talking about that weird bee-looking character is in. Where's the street what?
Why is the street invalid? Invalid street 611.
It's, the street name actually refers to a war-wounded hospital that used to be on that street like 150 years ago. So the street itself is not invalid. It actually refers to invalids, okay? So it's a historical name. But yes, I've heard that joke before. So how on earth, it's not even particularly consistent. So how do we get this information into our APIs? This is where a geocoder API comes in handy. A geocoder is basically a clever database that takes these street names and converts them into latitude and longitude. And there's also such a thing called a reverse geocoder, which, well, it kind of does the reverse, right? You take a latitude and a longitude and it gives you a street address. And you can imagine where this is useful, because in many cases, if you have customers, they will probably give you a street address, right? If you address a package and send it to someone, you don't write a latitude and a longitude on it, but I can guarantee you that in many steps in the process of getting that package to your door, a latitude and a longitude is used. And to get that conversion, people use a geocoder. Or if you have an application where somebody drops a pin on a map to tell the driver where to pick you up, you also want to display the address so that the person can actually verify that the pin is dropped in a place that the person recognizes. So this is a very useful, very important core feature of kind of location technology. And both of those things we see here, and we see the APIs, again, fairly simple. There's an endpoint. Again, I've removed the authentication, but beyond that, you'll really just have a search text parameter, and you put the text in, and that's it. And the reverse geocoder is a little bit more complicated in that it has several modes, though the mode we're all really interested in is retrieve addresses, which returns the closest street address. And then we can put in with a prox parameter a location. What I've not done here is put in a radius, but you can do this. So for example, if you have used the positioning API earlier and it's giving you that 166 sort of accuracy value, you can actually put that in there. So we can look at those in action also. Look at the geocoder API here, hit the send button, and that actually gives us a lot of information. One that's maybe interesting is we have a match level here, and that basically tells us that the result we get is actually accurate down to a house number. And that's quite relevant, because we could have, for example, put in the address without a house number. It still would have found a location, but it would have only been accurate to the level of the street. It would have probably put the location, which we can end up finding down here, probably in the middle of the street, and you need to know how to interpret that result, right? If we use the reverse geocoder, we can see the results actually formatted very similarly. And in fact, we get, and I appear to have screwed up here and put in a slightly incorrect latitude and longitude. This is a street very close to the Berlin office. And what's also nice is you see here that the address is really broken down into its constituent parts, so you can really figure out which one is actually the postal code, which one is the house number, and all these kind of things. We just talked about maps essentially being a type of context for a latitude and a longitude that helps us make sense of that. There's more context that is possible, though. For example, if we're in a certain place, we often want to know what's around us in terms of places or points of interest. For example, you may have just landed in San Jose, your talk isn't finished yet, so you might want to find a Starbucks where you can sit the day and frantically finish up your final slides with a nasty cold on top. And so finding places and points of interest around us is very useful. Similarly, it's not just always about where we are, but also about trying to figure out where we want to go. Sometimes we have a very precise location of where we want to go, but sometimes we kind of are seeking more of a service. Like, I need to find a gas station while I'm driving with my car, right? And finding these things is something you do with a places API. So basically, again, that is a database of places, points of interests, cafes, gas stations, hospitals, all the kind of things you imagine around you. And we'll switch to JavaScript again, because why not? So we've set up our platform, location platform object before, and we use this to get a search entry point, and we just give that two parameters. And one is a query string, which if we're looking for Starbucks would, for example, be Starbucks, and we give it a location. And what that tells the API is, please find me all the Starbucks that are close to this location. And then we just fire off a request with an onResult callback message in it. And if we look at this, I've broken this out into a separate file because there's a little bit more code. We can see down here we have all the boilerplate we talked about earlier. And up here we are basically in an add to places function, which is down here. We are parsing the results that we're getting from the places API. And if we look at that in action, what we should get is a nice little map where we basically drop pins on the map where all the Starbucks near my hotel here in San Jose are. Yes?
Where does this execute? In the mind of God on Google servers? Or?
No, this is executed on our servers. So this is a database that we have, we build, we maintain. You send the request, and it's executed on our servers. Okay. So you can see this too. You can very easily start drawing things on the map. If we go into this add to places function, then really all that's happening here is for each result that comes out of the places API, we're creating a marker object, and we're adding that marker object to the map in a latitude and longitude that's also in that result. And these markers are highly customizable, but by default, they'll just have this little blue drop pin that you would expect. So it's very easy to draw on the map. You can also just add like a polyline to draw a line, and all you feed it is a few latitudes and longitudes, and you can draw on the map, and it gets automatically rendered. So even visualizing things on that map is fairly easy. This is kind of how that code looks. This group object up there is essentially a way of just giving a hierarchy to these objects. We wouldn't have to use that, but there's a nice set view bounce function, and particularly the group has a nice get bounce function that helps us just zoom on the map in exactly such a way that all of those places are visible at the same time. So that's a very nice function right there. I think one core kind of location API that we use very, very regularly is still missing, because we've sort of figured out where we want to go. We figured out we want to go to the airport or to a Starbucks, but how do we actually get there, right? And that's what a routing API does for us, right? Essentially, a routing API based on some constraints, like I want to walk, or I want to drive by car, or I want to drive by bike, gives us a route to that location. So if we look at an API like this, again, it doesn't have to have a lot of parameters. You basically give it waypoints, and it needs at least two waypoints, a start waypoint and an end point, but you can put a lot of other waypoints in between. And you have to give it a mode. In this case, we say we want the fastest route. You can also say I want the shortest route. We say we want to go by car. Again, you can do public transit. We have a truck routing feature, because actually a route that's valid for a car is not necessarily valid for a truck. In fact, it might be illegal for it to drive. If there's, for example, something poisonous in the back, you're not allowed to drive near the water supply. So that might end you up in prison, or at least with a hefty fine if you set that parameter wrong. And you can also say, do you want to take traffic into account or not? So we also have live traffic information from many cities in the world, and that will actually take it into account when you're running that routing algorithm. So we can have a quick look at that as well. Actually, I think I did that as a Postman example. So again, we see the various parameters here. If we send this in, We get another JSON response. This one is fairly long, but the interesting stuff sort of starts to happen here when we're talking about maneuvers, right? For each of those maneuvers, we get a position, a latitude, and a longitude. We get some instructions, so it would say head toward Charcot Avenue on North 1st Street, go for 1.2 kilometers. And it tells you how long it takes to travel that, so that's 108 seconds, which is not very long. It tells you how long that actually is to drive, and then you get to the next maneuver. So each individual step of the road is there for you in all the details that you need. Oh, Google Maps has this as well, though they would be a competitor. But this is used, for example, in a lot of car navigation systems. So you've probably used this very routing algorithm very, very frequently. Many, if not most, car manufacturers are customers, right? So you've used this routing API probably quite a few times in your life without ever noticing. So, okay, we have about 5 minutes left. So one thing I still want to talk about kind of is, to some degree, you could argue that location is kind of solved. I talked about this earlier. It's become so ubiquitous, so standard for us to use this technology in our everyday life that we could sort of go and say, well, this is nice, but it's not exciting new technology anymore. We'll use this, but it isn't cool. However, the future is coming. And the future means we'll have a crazy amount of people on the Earth, and it'll be increasingly living in cities. That creates a whole new challenges. We have to create entirely new mobility concepts. I'm personally secretly hoping the hoverboard will finally appear, but it's probably not going to be quite that. There's also exciting new technologies. We have autonomous cars, really autonomous everything in our future. We're going to be living in an autonomous world not too many years into the future. And we also have things like an enormous amount of data, location data being generated, right? Everything is going to be a sensor. I mean, in many ways, you are a sensor. You're carrying a sensor array in your pocket, right? The phone, it takes pictures, and it can detect light and sound and vibration. And every single bit of data that's generated on that phone has a location context associated with it because you're carrying it around. And a lot of that data only makes sense with its location context. So in many ways, we really need to build a new location technology for the future. And because I'm about to run out of time, I can't talk too much about this, and it's intended as a bit of a teaser if you want to have a discussion with me afterwards. But we're building a new type of location platform, which we're calling the Here Open Location Platform, which is really intended to solve these issues. And if you want to know more about that, I would love for you to come to me and talk to me afterwards. I'll be here for the whole weekend. And that's pretty much it. Abe Lincoln is a reference to a slide I had to cut for time reasons, so you can also ask me about that later on, or just do what he says. He's a good man. Go and sign up on developer.here.com and make the grave fundamental mistake of following me on Twitter. And we have some time, so I'm happy to answer questions. Let's start here.
Okay, so I have a lot of questions. To be fair to everybody else, I'll ask them all, and you decide which one.
Okay.
Data collection points, which are discrete, but trying to kind of show the heat maps based on those. And then the last one, I'm interested in your perspective on what you think are some of the very interesting or challenging computational problems that you're solving. Not necessarily, having the scalable deployment to support all of those API requests, but computationally, what's interesting.
Okay, so these are all interesting. Since this is an introduction to map and location APIs, I'm going to pick the one that can be answered with an API, which is the one in the middle. We have a specific heat map API, which is fairly easy to use, which allows you to do more than just put maps on sort of map markers on there, which allows you to do exactly that. We also have a very, very powerful geovisualization API that allows you to do this with large amounts of data. That's a bit more complicated to use, so not something I can do in a very short intro to first location API technology, but if you go to developer.here.com and go look at the geovisualization API there, you will find something that will help you do that. Yeah, so I think some interesting stuff that we're looking at as a company, and I don't work in those departments, so I don't want to speak too much. Yeah, sure. I think one of the interesting things that we're looking to do is something like, for example, self-healing maps. And that goes back to what I said, everyone is a sensor now. That's particularly true of cars, right? If you buy a new car now, it has a sensor array in the front because it has some sort of, probably a maximum of level 2, but some sort of self-driving capabilities. And that starts sucking up a lot of interesting data, right? So a very simple example of that is you're driving down a corner and there's some ice in the corner. And what happens is your traction control triggers and your car starts to slide a little bit, a little light flickers in your dashboard, you don't die, hooray. But wouldn't it be nice if you could actually go and tell everyone else in the world that there's ice in the corner so that the car that comes after you actually either has a warning, or maybe the routing algorithm will take that into account and never tell the person to drive along. Or if it's an autonomous car in the future, the car will actually know to take that corner very slowly or drive around it, and you sitting in the car will never know. But another application is also just sort of what we call self-healing maps, right? You drive down the road and the road is closed, or there are massive potholes on the road, and you can collect that kind of data and put it back in the map. So the map actually gets automatically updated. It turns, and with those two things, it kind of turns from this somewhat static map into really a live map, and we call this a reality index, right? I sort of like to think of it as kind of a virtual mirror world, a live database where you can query the state of the world at any given place in the world and get something back. And to build this, of course, with self-healing maps and so on, I think there's lots of interesting applications for things like machine learning in there. And hopefully that also sort of answers a little bit like your third question. Obviously, we're as a company very interested in autonomous driving and self-healing maps and all this kind of interesting, fascinating stuff for the future. There's a question in the back. Yeah, so actually you don't need to connect this to anything else. I haven't shown those parameters, but you can basically tell the map that you want it to be displayed in a certain language. So you can add to those map APIs that I've showed you earlier, you can add another parameter and basically say, show me the street names in this language or this language or this language, right? Similarly with the two maps I've shown you where there's different political views on a map, you can basically say, show me the map from the perspective of Argentina and show me the street names in Spanish, right? And that's how then you would probably display a map to customers who are living in Argentina, right? Whereas if you have a map that's maybe for tourists, you might want to have as much as possible maybe labeled in English so that the pharmacy is actually labeled as a pharmacy, not in English and not in Spanish. And if you go over to Chile and you sell to Chilean customers, you might want to show a slightly different perspective on that map, right? But you can just set that with parameters. That's all part of the map data in multiple languages. Well, there's two ways of doing that. First, you would ideally actually plug into the city and get that information from the city, right? So ideally, the city would make that data available, and you would just put it immediately into the map. Exactly. Yes, But even there, you can have that information with very little delay, because the first car driving down that route will immediately see that there is a blockage there, right? And it can report that back, and then of course you have to come up with smart algorithms to figure out, is this actually something that's worth rerouting other people that are behind around? So that's not a trivial thing to do. But you can imagine algorithms that sort of determine, is this just a short-term thing, it's just someone briefly wandered onto the street and it's going to be clear again in a minute, or is this something where we need to act now and try to route other people around later on because there is a blockage. And then eventually the first car, once it's been removed, the first car that'll go through will again will be able to write back into the map, oh, the road is clear, there's no problem here, right? And you can remove the rerouting again. So I think the sort of midterm answer is the here open location platform, which is I've talked about this example with the car going around the corner, and you create this location data, right? The here open location platform is a big data location platform that allows you to take in that data, to transform that data, to use all of the services we've talked about and a lot more on that data, visualize that data, gain insights from that data. But more interestingly, also take that data and sell it on. There's a marketplace attached to that. So if you're a company and you're generating this kind of location data, you might go to take your location data, go to the marketplace, take someone else's location data that's interesting to you, take that data, transform that data, create a new and interesting data set, put that on the market again, generate a new revenue stream for you. Other companies might use that. So that's kind of for developers, and this is not out yet. So this but it will hopefully be available soon. Again, you can, we'll let you know should you have signed up on developer.here.com about news on that. So that is sort of the really interesting future perspective. For the rest, I would argue you can look at the quality of the services and the quality of the maps and compare and pricing, and that's sort of the solve part of location. Our stuff there is really great and really useful, and I think you have to look at the individual use case, which one works best for you. That is. Yeah, so well, that's true. If the southern thing is Indonesia, then see now I finally understood the map. It's not as bad as it sounds, and you're right. Even the dragons are actually real.
They're not Western dragons; they're Eastern dragons.
So that's actually pretty cool. I finally understood that map. So you've taught me something, which is really cool. I think I've made the mistake of implicitly assuming that the map was aligned according to north, which it's not, right? It still doesn't make that much sense, like the Solomon Islands aren't that close together and all that kind of stuff, but actually, okay, so I've done a long-dead Dutch man some injustice. The dragons are actually real. I apologize. Which are incredibly cool. So, I might have to change that drawing, that picture of the dragon for the next time I do this talk. Any more questions? There's a question. Yes, exactly. So we have an actual free tier, which allows you to use most of the things I've shown you, even for commercial use. I think you get 10,000 transactions a month. After that, you need to charge. What we also have is a 90-day free trial, which gives you pretty much the entire platform that we have, even a lot of the advanced features we didn't have time to talk about today. And that also gives you 100,000 transactions, so that really is fairly generous and allows you to really play with that stuff for quite a while and extensively. So have fun with that. Okay, thank you very much for your attention.